Okay, class, today we're going to continue with our section on geometry, and specifically today and upcoming classes we will be looking at recognizing properties of triangles. And here is a visual for you to see what a triangle is, and eventually we might be even able to show how this is possible. So first we need to look at polygons, which is going to be crucial for us to understand what a triangle is and how to use it. So a polygon is a closed two-dimensional shape with straight sides. And there are three examples that we're going to look at in this class. The first is a triangle, which is what the focus of this next lesson is going to be about. Second is rectangles, or any four-sided figure, which we will eventually work towards later in the week. Third is pentagons, which are five-sided figures, and we can even possibly conjecture larger sided figures based on what the properties we see from these three. Now we do know some figures that are not necessarily polygons. A circle, because it has a curved side. It is a closed figure, but since it has no straight sides, we cannot specifically define it as a polygon. And a second is any unclosed figure, which I have as an example over here. As you see, there are 2 points that do not connect together in an open space, therefore it's not closed. So now we're going to look at side and angle recognition, which are properties which is part of our properties section. Every polygon has n sides, where n is the number of sides which determines the name of that polygon. For example, a triangle has 3 sides, a rectangle has 4 sides, a pentagon has 5 sides, and so on and so forth. Now here's a picture of a four-sided figure, and it shows this thing called a vertex, which we'll get to later, and then where the actual side is. And since every polygon is a closed figure with sides, it stands to reason that they also have angles. And if you're going to look at this next picture, there are 3 sides and 3 different angles, all labeled by A, B, and C. And this example works well because it is a triangle, which is the focus of the upcoming class. An angle is the amount of turn between 2 straight lines that have a common endpoint called the vertex. So here's that vertex thing again, and we're going to look at it by looking at what they call the 2 arms, which can be legs, lines, however these words are interchangeable. But the vertex is the point of intersection between them, and the angle is the measurement of the space in between the projection of the vertex, or the space in between the 2 arms. Now we're going to look specifically at what a triangle is. And there are 3 different types of triangles. The first is a right triangle, which is a triangle that has one 90-degree angle. Now if you look at this picture, it clearly has labeled 90 degrees, or that square box, which is based off of perpendicular lines they create, and by the definition of perpendicular, that makes it a 90-degree angle. These triangles are going to be very useful for a theorem we're going to be able to work with in the next class. Next is an isosceles triangle, a triangle that has 2 congruent sides and angles. And notice the word congruent. Congruent is almost interchangeable with equivalent, but not necessarily. And an isosceles triangle has 2 congruent sides, which you can see are marked right here, and 2 congruent angles, and is based upon the definition of isosceles. The third type is an equilateral or equiangular triangle, a triangle that has 3 congruent sides and angles. And here's the example of it. You see 3 congruent sides, 3 congruent angles. Now, if based upon the markings of the figure you're given, if it's just the 3 sides that are listed as congruent, it follows their angles are congruent as well. But if it's just the sides mentioned, that is equilateral. If it's the angles, then it is equiangular. It's based upon what you need in terms of the context of the problem. Now we're going to look specifically at angles and their measurements. So there are 3 types of angles. First is an acute angle, which is an angle whose measure is less than 90 degrees. And again, that 90-degree marker is very important for recognition. As you can see in this angle, A, it is clearly less than 90 degrees, because if it was, it would be a straight perpendicular line up this way. So therefore, that is the way visually to see that. Our second type is an obtuse angle, which is an angle whose measure is greater than 90 degrees. And as you can see, this angle is greater than if you dropped a perpendicular down through. And then now we're going to look specifically at right angles, which is an angle whose measure is 90 degrees. As you can see, we've seen it from the triangle, and if you were to connect this to this, that would make it a triangle. But again, you drop the perpendicular to the baseline, and this square is created, which is 90 degrees. So now we're going to look at some specific triangle properties. And one of them is the base of a triangle can be any one of the three sides, usually the one drawn at the bottom. And normally in class, that's the one we're going to normally see. The vertex, which we mentioned earlier with angles, is in terms of a polygon, is at the corner of the triangle, and every triangle has three sides. And this would be true in conjecture with a four-sided figure, a five-sided figure. Each corner would represent a vertices, and a rectangle would have four vertices, a pentagon would have five vertices, so on and so forth. The altitude of a triangle is perpendicular from the base to the opposite vertex. And we're going to look at this picture to get a better picture of what all three of these are. The base is labeled right here, and it is the bottom side, and there are three sides, so that one is consistent with our definition. Our vertex, or vertices, are right here, and right here. And if we were to look at this, you can see where the angles are formed, which again goes back to our previous definitions. Now the altitude of a triangle is perpendicular from the base of the vertex, and again we've been talking about this term perpendicular. Now in this picture they call it height. Height and altitude again are interchangeable in geometry. Now this dropped line is the perpendicular line, and we can see that because of the 90-degree angle. And it's dropped from a vertice to the base, which is a very important feature, or the base dropped up to the vertex. Either way you look at it, that is how you determine the altitude. So what I want you to do for the start of next class, write down what you think of all these definitions and properties and where they're going to be used for in class. And I want you to draw your version of a right triangle and an isosceles triangle, one on one side of the paper, the other on the other side, and then bring that to class. And then I will see you when we start class tomorrow.